astrophysical object in 3 dimensions with great resolution for the very first time. We've seen the sun from the dawn of humankind. We are here because of the sun. But what we haven't seen is the view that we are going to get from the stereo spacecraft. And that's a 3-dimensional view. This is going to change the way we view the sun forever. It goes back to the Lewis and Clark race, essentially. We're just moving from one frontier to the next. We are venturing out where we do not have the protection of our own planet. What we are going to find, we do not know. We do not know.
In space weather forecasting, the stereo mission is going to give us an insight much like the Doppler radar did for weather here on Earth. When we see the eruptions in the sun, we call the coronal mass ejection a CME. We'll be able to have a side view of them for the first time to see how they expand. We're going to be able to watch the CME as it travels the 93 million miles from the sun to Earth.
CMEs are considered to be the most violent explosions in our solar system. A tremendous amount of mass can be ejected out, traveling at a speed of more than 1 million miles per hour.
Would be the equivalent of millions of 100-megaton bombs exploding at the same time.
If the orientation is right, then it can really pack a huge punch on Earth's magnetosphere. That's the magnetic bubble, the cocoon that protects the Earthlings from the harmful radiation of the sun. These solar storms can cause real devastation to our power grids and our satellite communications. We are in an era where we have introduced this concept of space weather because it matters to us now. We are studying the sun and Earth as a coupled system, not individually. And that new science is called heliophysics.
It will be revolutionary. In any case, when you see more, you suddenly have insights you've never had before. Up until now, our situation has been like trying to diagnose the ocean with one buoy.
Stereo is a 2-spacecraft mission, and both spacecraft will be in orbit around the sun, but not in the same place. They're going to be separating from each other, and that will give us 2 eyes on the sun. We're going to be seeing the sun in 3D.
With the stereo spacecraft, we're going to improve space weather prediction by a factor of 2.
The 2 stereo spacecraft are incredibly complicated. There's a suite of 16 instruments on each one, so extreme care had to be taken while putting them together. Everybody was in full clean room suits to guarantee we keep the instruments as clean as possible so that they'll operate correctly in orbit.
When we have launches, we don't think about is that there are so many things you have to do right to make it work. And all it takes is a small little thing to make it go wrong. Yes, you are as if brain, holding on to your breath.
spacecraft were launched together. We blow the bolts, and they separate. Minutes later, we release the solar panels. They come out in two ways. Once that happens, they start making their own solar power. Also point an antenna back at Earth to get all the data down for the science team. It's a tricky operation with lots of special commands to make sure all of our instruments are set up correctly. There are 3 antennas that measure radio waves. These are 20-foot long tubes that telescope out. From that point on, we slowly opened up all the doors that had built up pressure during the flight. And then we finally ramped up to their full power and said, "We're ready to go." Mission Control is at Johns Hopkins Applied Physics Lab in Maryland, and it's like a scene out of a science fiction movie. They have it divided into 2 teams, one for each spacecraft. To get the twin stereos into orbit, we placed one ahead of the Earth and one behind the Earth. Having both spacecraft, one on either side, gives us the 3D images of a sun that we're all looking forward to. There's a number of ways in which this mission is about seeing the invisible. We think of the space in between the sun and the Earth as being a vacuum. But it's filled with the solar wind, which is the sun's super hot atmosphere flowing out into the solar system. You can think of a coronal mass ejection as being a storm in the solar wind. Many of these storms are accompanied by high-energy particles that can interact with the Earth's magnetic field.
We're extremely interested in what happens in the sun because we live in the atmosphere of the sun. So if the sun sneezes, the Earth will catch a cold. Fortunately, we have the magnetosphere that acts almost like a Kleenex and keeps out most of the nasty radiation. If you had a bird's eye view, it would look a little bit like a magnetic squid.
Some of these particles can actually get inside the polar regions, which create these beautiful lights, the southern lights.
When you see the aurora, I think everyone who sees them for the first time is just blown away by how beautiful they are. They really do look like shimmering curtains of light blowing in the breeze.
These northern lights that you see, people don't realize that this is just not sight, but there is also sound. This is arts.
You seriously can be standing outside at minus 30 degrees looking at these and you don't notice how cold it is. But within this very beautiful phenomena, there can lurk some danger.
NOAA, the National Oceanic and Atmospheric Administration, is responsible for space weather forecasting at the Space Environment Center in Boulder, Colorado. We monitor space weather 24 hours a day, we have that responsibility to warn the public that something's happening in the sun that might affect us right here on Earth. We're watching big sunspots on the sun, measuring their size and their complexity.
This is the home base where CMEs begin. This is where active regions are twisted and bent, and eventually they erupt, producing this solar blast.
When we see the eruptions on the sun, we'll start sending out warnings that a large solar storm is in progress. When this actual eruption occurs in the sun, we start seeing impacts on us immediately right here on Earth.
Space weather for the next 24 hours is expected to be severe. Geomagnetic storms reaching the G4 level, solar radiation storms reaching the S2 level, and radio blackouts reaching the R3 level are expected.
On the 6th of December 2006, a volatile sunspot cluster appeared in the sun, resulting in a powerful eruption. This actually produced the largest solar radio burst we've ever observed.
We didn't expect there to be a large solar radio burst during the quietest part of the solar cycle.
It just came out of nowhere. It was 10 times bigger than we had seen before, ever. It was an incredible surprise.
We were counting the number of GPS satellites that were on track, and normally every 30 seconds you're seeing 10 satellites, 10 satellites. All of a sudden it goes down to like 2, 1. I mean, it's like there was this huge effect.
Pretty much every GPS receiver in the hemisphere was affected. Many of them just failed outright, ceased to be.
It only happened on the sunlit side of the planet, but it was instantaneous and it was global.
Unlike a CME, this solar radio burst is traveling at the speed of light, so it reaches Earth in 8 minutes. And this solar eruption resulted in flights being rerouted away from polar routes.
2404 Los Angeles Tower with 20010, Air 2018.
This extraordinary behavior burst itself affected air traffic controllers across North America. Well, now we have to stop everything and rethink this situation. What is the biggest we could possibly get? We just, of course, don't know.
As a society, we become more and more reliant on technology. Nobody leaves home without a cell phone. People have GPS receivers in their cars. You don't even think about the possibility of not having electricity.
We have power grids that are very sensitive to the electric current that's caused by these particles, which can cause severe blackouts, rundowns. Question is, are we ready for this?
The satellite operators recognize that space weather can have a significant impact on their spacecraft. They can actually point it in a different direction to protect it from these high-energy particles that are coming from the sun.
Humankind is destined to move away from Earth orbit. We're going to be in the harsh, rude environment of the sun's domain.
For missions to the moon and to Mars, we've got a big problem. We've got to understand how we're going to protect the spacecraft and the astronauts from the radiation that occurs during these big eruptions of the sun.
To understand and to be able to accurately predict when these particles might be coming at us is going to be very important. I can't imagine any other missions that are more directly relevant to humankind. By studying the sun, we are understanding this object that influences our life in every conceivable way. But to view that in 3D, I really can't quite envision myself. I get emotional if I think about it. These are the very first 3D images from the stereo mission in their full glory detail. This cauldron of magnetic soup putting out loops, jets, spikes. It's churning constantly. We used 4 colored filters. They revealed the different parts of the sun at different temperatures. We show the coolest temperature through the blue filter, where you see these dark regions that are called coronal holes. That's where the solar wind is blowing out of. You also see these beautiful rays called polar plumes that kind of juts out forever. When you see these coronal loops, they come from the hottest parts of the sun. This is where coronal mass ejections can erupt from. Because of stereo, we are going to understand the true 3D shape of all these structures. We will be able to better predict how much energy is stored inside these loops. This will help us solve some key mysteries of the sun. What touched me the most is this young kid with glasses on, pointing his finger and saying, "I can as if touch it." That's the first reaction of the 3D sun for the rest of the world. It's just jumping out at you. I've always been fascinated